Section 408.3d of the National Electrical Code specifically addresses the requirement for spare spaces within panel boards. This section is essential for ensuring electrical systems can accommodate future expansion and modifications without requiring complete panel board replacement. The core of 408.3d stipulates that panel boards rated 100 amps or less must have a minimum of 4 spare spaces available for the installation of additional overcurrent devices. These spare spaces are intended to provide the necessary capacity for adding new circuits or modifying existing ones as the electrical needs of a building or installation evolve. The purpose of this requirement is multifaceted. Firstly, it acknowledges that electrical demands often increase over time. As technology advances and occupants acquire new appliances and equipment, the need for additional circuits can arise. By mandating spare spaces, the NEC aims to prevent situations where existing panel boards become overloaded or inadequate, leading to potentially unsafe conditions. Secondly, the spare space requirement promotes flexibility and adaptability in electrical systems. Instead of having to replace an entire panel board to add a single circuit, electricians can simply utilize one of the available spare spaces. This reduces costs, minimizes downtime, and simplifies the process of upgrading or modifying electrical installations. Thirdly, the requirement enhances electrical safety by preventing the unsafe practice of overloading existing circuits. When panel boards lack sufficient capacity, there is a temptation to add circuits by tapping into existing ones or using inappropriately sized overcurrent devices. These practices can lead to overheating, insulation damage, and an increased risk of electrical fires. By ensuring that spare spaces are available, the NEC discourages such unsafe practices and promotes the installation of properly sized and protected circuits. The scope of 408.3d is clearly defined. It applies specifically to panel boards with a rating of 100 amps or less. This means that larger panel boards typically found in commercial and industrial settings are not subject to the same requirement for 4 spare spaces. However, good electrical design practice often dictates that even larger panel boards should have some spare capacity to accommodate future growth. It's important to understand what constitutes a spare space under the NEC definition. A spare space is a location within the panel board designed and intended for the installation of an overcurrent device, such as a circuit breaker or fuse. The space must be readily accessible and free from obstructions that would prevent the installation of the overcurrent device. The space must also be properly sized and configured to accommodate the type of overcurrent device that is intended to be used. It's also important to note that the requirement for spare spaces applies to the initial installation of the panel board. If a panel board is already installed and has fewer than 4 spare spaces, it is not necessarily a violation of the NEC. However, if the panel board is being modified or upgraded, the requirement for spare spaces may be triggered, depending on the nature of the modifications. When selecting a panel board, it is crucial to consider not only the current electrical needs but also the potential future needs. A panel board with sufficient spare spaces will provide greater flexibility and adaptability over the long term. It is also advisable to consult with a qualified electrician to determine the appropriate size and type of panel board for a particular application. The electrician can assess the current and future electrical demands and recommend a panel board that meets those needs while also complying with all applicable NEC requirements. In addition to the specific requirement for spare spaces in 408.3d, other sections of the NEC also address the issue of panel board capacity. For example, Section 220.87 provides guidelines for calculating the load on a panel board. This calculation is used to determine the appropriate size of the panel board and the number of circuits that can be safely installed. It's important to ensure that the calculated load does not exceed the rating of the panel board. Furthermore, Section 312.8 provides requirements for the wiring space within panel boards. This section specifies the minimum amount of space that must be provided for conductors and other components within the panel board. Adequate wiring space is essential for ensuring proper heat dissipation and preventing overcrowding, which can lead to insulation damage and other problems. In practical terms, complying with 408.3D involves several steps. Firstly, when designing an electrical system, it is necessary to accurately assess the current and future electrical demands. This assessment should take into account the number and type of appliances, equipment, and lighting fixtures that will be connected to the panel board. Secondly, when selecting a panel board, it is crucial to choose one that has sufficient capacity to accommodate both the current and future loads. The panel board should have enough spaces for all of the required circuits, as well as at least 4 spare spaces for future expansion. Thirdly, when installing the panel board, it is important to ensure that all of the wiring is properly sized and installed in accordance with the NEC. The conductors should be properly terminated and secured, and there should be adequate wiring space within the panel board. Fourthly, after the panel board is installed, it is important to periodically inspect it to ensure that it is in good condition and that there are no signs of overloading or overheating. Any problems should be addressed promptly to prevent potential safety hazards. The requirement for spare spaces in 408.3D is just one example of the many ways in which the NEC promotes electrical safety and reliability. By following the NEC and other applicable electrical codes, electricians and electrical designers can help to ensure that electrical systems are safe, efficient, and capable of meeting the evolving needs of buildings and occupants. It's also important to remember that electrical codes are constantly evolving to reflect changes in technology and best practices. Therefore, it is essential to stay up to date on the latest code requirements by attending training courses, reading industry publications, and consulting with qualified electrical professionals. In summary, Section 408.3D of the NEC requires a minimum of 4 spare spaces in panel boards rated 100 amps or less. This requirement is intended to provide capacity for future expansion, promote flexibility and adaptability, and enhance electrical safety. Complying with this requirement involves careful planning, proper panel board selection, and adherence to all applicable electrical codes and standards. By following these guidelines, electricians and electrical designers can help to ensure that electrical systems are safe, reliable, and capable of meeting the needs of buildings and occupants for years to come. Furthermore, consider that panel boards come in various sizes and configurations, often denoted by the number of available circuit breaker spaces. Common sizes include 12, 20, 30, and 42 spaces. When selecting a panel board, it is crucial to consider the existing and anticipated future electrical loads, as well as the physical space available for installation. A larger panel board may be necessary to accommodate future expansion, even if the current electrical load is relatively small. Also, remember that circuit breakers are designed to protect electrical circuits from overloads and short circuits. They are available in a variety of sizes, typically ranging from 15 amps to 200 amps or more. The size of the circuit breaker should be matched to the ampacity of the circuit conductors and the load that it is intended to serve. Installing an undersized circuit breaker can result in nuisance tripping, while installing an oversized circuit breaker can create a fire hazard. When adding a new circuit to a panel board, it is important to follow all applicable NEC requirements for wiring, grounding, and overcurrent protection. The circuit conductors should be properly sized and installed in accordance with the NEC ampacity tables. The circuit should also be grounded in accordance with NEC requirements to provide a path for fault current to return to the source. And most importantly, the circuit should be protected by a properly sized circuit breaker that is installed in a spare space within the panel board. Never attempt to add a circuit to a panel board by tapping into an existing circuit or by using an inappropriately sized overcurrent device. These practices are unsafe and can lead to serious electrical hazards. Always consult with a qualified electrician if you are unsure about how to properly add a circuit to a panel board. They can assess the existing electrical system, determine the appropriate size and type of circuit breaker, and ensure that the installation complies with all applicable codes and standards. In addition to the NEC, other codes and standards may also apply to electrical installations. For example, local building codes may have additional requirements for electrical work. It is important to be familiar with all applicable codes and standards before starting any electrical project. By adhering to these codes and standards, you can help to ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. Think of panel boards as the central distribution points for electricity within a building. They receive power from the utility company and distribute it to various branch circuits that serve different areas and appliances. The panel board contains a main breaker that protects the entire panel board from overloads and short circuits, as well as individual circuit breakers that protect each branch circuit. The circuit breakers are designed to trip or open the circuit if the current exceeds the rated ampacity of the breaker. This protects the wiring and appliances from damage and prevents electrical fires. Understanding the basic principles of panel board operation and circuit breaker function is essential for anyone who works with electrical systems. It is also important to be aware of the potential hazards associated with electricity and to take appropriate safety precautions when working with electrical equipment. Always to energize the circuit before working on any electrical component. Use insulated tools and wear appropriate personal protective equipment such as gloves and eye protection. And never work on electrical equipment if you are not qualified to do so. If you are unsure about any aspect of electrical work, consult with a qualified electrician. They can provide expert advice and assistance to ensure that the electrical system is safe and compliant with all applicable codes and standards. Now, let's consider some specific scenarios where the spare space requirement in 408.3d might come into play. Imagine a homeowner who is renovating their kitchen. They plan to add new appliances such as a dishwasher, a microwave, and a garbage disposal. Each of these appliances will require a separate branch circuit with its own circuit breaker. If the existing panel board does not have enough spare spaces to accommodate these new circuits, the homeowner will need to either replace the panel board or add a subpanel. A subpanel is a smaller panel board that is fed from the main panel board. It provides additional circuit breaker spaces for adding new circuits. However, adding a subpanel can be more expensive and time-consuming than simply replacing the main panel board with a larger one. Therefore, it is often more cost-effective to choose a panel board with sufficient spare spaces in the first place. Another scenario is a small business owner who is expanding their operations. They plan to add new equipment, such as computers, printers, and machinery. Each of these pieces of equipment will require a separate branch circuit with its own circuit breaker. If the existing panel board does not have enough spare spaces to accommodate these new circuits, the business owner will need to either replace the panel board or add a subpanel. In this case, it is even more important to choose a panel board with sufficient spare spaces, as the business owner may have limited time and resources to devote to electrical upgrades. Adding new circuits to a panel board is not always a simple task. It requires careful planning, proper wiring techniques, and adherence to all applicable codes and standards. It is always best to consult with a qualified electrician to ensure that the job is done safely and correctly. The electrician can assess the existing electrical system, determine the appropriate size and type of circuit breakers, and ensure that the wiring is properly installed and grounded. They can also help to identify any potential hazards or code violations and recommend appropriate solutions. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take the necessary safety precautions when working with electrical equipment and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can help to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. In addition to the technical aspects of 408.3d, it's also important to consider the economic implications. While the initial cost of a panel board with more spare spaces may be slightly higher, the long-term benefits can outweigh the upfront expense. Avoiding the need to replace or add a subpanel later on can save significant money and time. Furthermore, having spare capacity available can increase the value of a property, as it makes it more attractive to potential buyers who may have future electrical needs. The decision of how many spare spaces to include in a panel board should be based on a careful assessment of the current and future electrical demands, as well as the overall budget and long-term goals. It is always best to err on the side of caution and choose a panel board with more spare spaces than you think you will need. This will provide greater flexibility and peace of mind, knowing that you are prepared for future growth and changes. Moreover, the location of the panel board within the building is also an important consideration. The panel board should be located in a readily accessible area that is free from obstructions and environmental hazards. It should also be located close to the main service entrance to minimize the length of the feeder conductors. The panel board should be securely mounted to a wall or other structural support. It should be properly labeled to identify the circuits that are served by each circuit breaker. The labeling should be clear, accurate, and up to date. This will make it easier to identify and troubleshoot problems in the future. Regular maintenance of the panel board is also essential for ensuring its continued safe and reliable operation. The panel board should be inspected periodically for signs of corrosion, damage, or overheating. Circuit breakers should be tested to ensure that they are functioning properly. Any loose connections should be tightened, and any accumulated dust or debris should be removed. By performing regular maintenance, you can help to prevent potential problems and extend the life of the panel board. When working with electrical systems, it is always important to prioritize safety above all else. Electricity is a powerful force that can cause serious injury or death if not handled properly. Always take the necessary safety precautions and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can help to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. Let's delve deeper into the specific types of overcurrent devices that can be installed in the spare spaces of a panel board. Circuit breakers are the most common type of overcurrent device used in modern electrical systems. They are designed to automatically interrupt the flow of current in a circuit when an overload or short circuit occurs. Circuit breakers are available in a variety of sizes and types, including single-pole, double-pole, and three-pole breakers. Single-pole breakers are used to protect 120-volt circuits, while double-pole breakers are used to protect 240-volt circuits. Three-pole breakers are used to protect three-phase circuits. Fuses are another type of overcurrent device that can be used in panel boards. Fuses are designed to melt and break the circuit when an overload or short circuit occurs. Fuses are available in a variety of sizes and types, including cartridge fuses, plug fuses, and blade fuses. Fuses are generally less expensive than circuit breakers, but they must be replaced after they have blown, while circuit breakers can be reset. Arc fault circuit interrupters, abbreviated as FSIs, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. FSIs are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, abbreviated as GFCIs, are a type of circuit breaker that is designed to protect against ground faults. Ground faults occur when current leaks from a circuit to ground. GFCIs are required in many areas of the home, such as bathrooms, kitchens, and outdoor areas. When selecting an overcurrent device for a spare space in a panel board, it is important to choose one that is properly sized and rated for the circuit that it is intended to protect. The overcurrent device should also be compatible with the panel board. It is always best to consult with a qualified electrician to ensure that you are selecting the correct overcurrent device for your application. Remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements to ensure that your electrical system is safe and compliant. You can do this by attending training courses, reading industry publications, and consulting with qualified electrical professionals. By taking these steps, you can help to ensure that your electrical system is safe, reliable, and capable of meeting your needs for years to come. And as technology continues to advance, new types of overcurrent devices may become available. It is important to stay informed about these new technologies and to understand how they can be used to improve the safety and reliability of electrical systems.